Alright, so my name is Dhrov, and I'm going to be doing the walkthrough to the software that I've created so far. Some parts of the software are complete, some parts of are under construction, and some parts I haven't even started on. So today's my last day, and I'm going to be handing it over to these two guys.
Yeah, and Ayman.
Yeah.
Alright, so first thing, we have the front panel of the actual UI. I've done a bunch of work for the UI, and the way I set it up so far is that there's a tab thing where we organize all our controls and indicators.
Yep.
Photocopy is going to be where, in the end, this is going to be where people go and they just click kind of photocopy, and this is like where they're going to have the options to just do the photocopying part of the thing. I haven't actually worked on this at all because this is kind of going to be like the end product. I worked on the setup tab. I'll explain this a little bit more. Development tab, you only see these like three things right now: the errors, ins and out, and there's a shifter down here. This can be very useful for debugging because you can see everything and it's going on with the program. And one more state that you guys are probably going to need to add here later, one more tab, is going to be manual control for the arm. Whether you do like a simple arm or delta arm or whatever, you're probably going to need another state just called manual control. And I don't know, you can be creative on what features you add to that. One thing I was thinking that you should try and use the joysticks, the loose joysticks we have. The code is pretty much done for you, a lot of it, in terms of how to actually implement the joysticks into your program. Just look at a bunch of examples. You can look at code that FRC students, FRC stuff uses, and so on, and try and incorporate that so you can actually control the thing with the joystick. Could be kind of cool. So I'm just going to go over the setup tab. The way the actual thing I'm thinking is going to work, like the actual photocopying, is going to take a picture of a bunch of Lego blocks upside down, and we're only going to deal with them upside down. It's just easier. And it's going to look at a bunch of scattered blocks, and it's going to know where it's going to need to first recognize where each block is and what type of block it is. So is it like a 4-piece block, or is it like a 3, or and what color it is. And once it knows that data, then when it goes to the photocopying state, it can use that data to pick it up and so on. So in the setup tab, you're going to set it up because that requires, for it to be able to do that function, go through that functionality and actually recognize where the blocks are, it needs some setup required before the program is run. So what you have to do is you have to first load the image. So let me just run the program here. So you click on load file, and what you do is you select a file. I'm just going to select this one. It's not actually Lego pieces, but it's just an example. And you can use the zoom to zoom in to this. And what you need to do first is you need to tell it where the Lego block is in the image, and it doesn't know what a Lego brick looks like. So you need to first tell it where it is so that it can recognize it and see patterns. And what you do is you click on a rectangle tool. I'm just going to use this, I guess, the capacitor here. And first you select it. You can adjust this depending. It's on the Lego brick. Just remember that it usually works better if you leave a little edge around it. Otherwise, it can't recognize that it's supposed to be a rectangle. So click Learn Template. This is the status. So this constantly updates. When this picture appears here and it says Learning Successful, that means that it learned all the patterns that it could find in here, and it knows what this particular thing looks like now. If you click search, it will search for whatever is in this indicator here. So if you click search, so you found these three, it says, oh, these three look alike. It didn't find this last one, so you can adjust these settings to make it work, whatever you need to do. I found balance works better. Yeah, see, it's not finding it today. So like yesterday when I tried it, my sample worked, and today it doesn't work. So maybe what you need to do is you need to select a better sample. Yep. So that rectangle, try and adjust it a little bit more so that it will find this other block as well, right? It's just a bunch of tweaking, and it also says how many matches were found. So 3 matches were found. Now, so say you're happy with the sample, right? You're happy with the sample you took, and you like it. So you click, you select what kind of sample it is. So the naming structure, the way I've set it up is, so the number represents how many holes at the bottom it has. That's usually 1 minus whatever's in front. So say it's a 4x1 brick, that means it'll have 3 holes at the bottom. So say if it was a yellow brick, 4x3, that means it would be called yellow 3. I'm just going to pretend this is a yellow one. So you select what kind of brick it is, and you go save new, and it says yellow 1.png saved successfully. So that basically means that it takes the pattern recognition data that it collected when you did the learn template, and it takes the image and saves it to file, so you never have to do the learn again. So if you come back later, like say if I was to exit the program right now, and I used to run everything, so everything's in a blank slate now. You go load file, you load the same file again, and now in here if you select yellow 1 and you go view current block, that block that we saved the last time is there, so we never have to do the learn template again. In this picture it's okay, it doesn't actually matter too much if we do the learn template every time. I mean, it does matter because you would have to select the rectangle every time. This is very helpful because our pictures are going to be fairly high res, and you can see how that takes significant amount of time to do the learning. The actual searching is fairly quick, but the learning template takes a decent amount of time, so it's kind of time saver. And you can save a whole bunch of files. Like I've already done this, so if I was to open this folder, what it does is when you click save new, it creates this folder here, saved scans, and it puts all the PNGs in here. So I've already saved these other files. You see this is a yellow 3 because it's got the 3 holes. It's a 4x2 brick, and this is our yellow 1 that we just saved, right? Equivalently, if you select a different brick, so if we wanted to see what yellow 3 looks like, and we can see that. And save, like I did this save like yesterday. I did this learn template yesterday. So if I go red 1, view current block, and click search, I found them, right? It does work usually. It's just tweaking with the numbers. You just have to play with the numbers, and you're gonna have to figure out exactly what works best. It's probably gonna be different for different lighting conditions, so you're just gonna have to play with that. There's a bunch of different resources you can use to kind of help you learn how the system is set up. So what you can do with like the actual color sensitivity and color and shape and the actual search strategy. If you click find all, then what it does is it looks for all the PNG files that are in this particular folder, and then it searches for each one of those in whatever sample you have here, right? So if I clicked find all, so you found 3 yellow ones, which was this one. I found 3 of those. I found none yellow 3s, which is this one. I found 4 red 3s, which is this one. Right, so clearly it's the exact same thing, but this sample was better, so I found 4 of these, only found 3 of these. Right, so that's kind of where the actual sampling goes. You're just gonna have to get used to it. And that's the basic UI that I've set up so far, but you can expand that. The actual which tag you put the indicator or the control on has no effect on the actual program. That's just however you want to organize it, because I could have just put everything on one page and that would just be confusing, so didn't. So now we're gonna go. Do you have any questions? Any questions?
Not yet.
Not yet.
No, it's all good. Cool.
Did you do all these algorithms? Recognition?
I didn't write the actual base stuff because it's already done for me, so didn't bother. And you can't look at it either because it's a library, so it just feeds into the library, so you can't look at how they do it. Okay, we'll start the program part of it now. I'll just talk about the actual base structure of the program. This is just to initialize. It just initializes everything, so it makes the blank shifter. The shifter, this shift register right here, this basically holds all the data, all the memory for the program. So if you need to remember anything, it's held in here. So this cluster, if you ever need to remember anything from state to state in the program, you would add it to this type def here. So this is the type def. So if you ever wanted to change something, you just go right click, open type def, and in here you could add anything you wanted inside the cluster. you can't just edit it from any point, but the advantage of this is that if you change it here, it changes everywhere automatically, so you don't need to go around changing. Like, say you added a boolean, you don't need to go around adding a boolean everywhere. It's fairly helpful. There's a bunch of other things that I've also made a type def, like the actual brick type. So if you wanted to add a new brick type of brick, so maybe now you want to use a blue brick, you just right click on any one of these brick type enums, go open type def, right click on this and go edit items. And in here you can add whatever you want, so insert and add any new brick you feel like adding. So, and then the second part of the structure is that we got the loop that actually runs everything. This is a string-based state machine. So this string right here contains all the states in a kind of in a row, and these two green VIs kind of monitor which state will happen next and what's happening right now type thing. So the way it works is that you got these two wires here. Whatever you put into the bottom wire will be added to the bottom of the queue. So if this already had data in it and I put in go to state number 5, then after all the states that are already in the queue execute, it will go to state 5, right? And what this does is like an error monitor, and it also kind of pulls out whatever's on the very top of the queue. So say this wire has like 12 different states in it that are supposed to happen in a sequence. What this will do will take the very top one, put it out here, and put the rest, not excluding the one that just executed, through this wire, right? So whenever there's nothing in the queue, it will go to nothing, which is the state here, right? So that means that there's nothing that is meant to execute right now. It's just waiting for next command. And also one more feature that this does is that if there's ever an error in here, then it will kind of cut the queue, and in the middle it will insert the error state, which is this one. So if there's ever an error, it will send everything to the error state. The error state clears the error and makes the dialog box, so it gives you a pop-up of whatever error happened. It makes it very easy to debug stuff.
Okay, awesome.
So I'm just to kind of explain how this event structure works. So I'm just going to give an overview of how this works. The way it works is that timeout state, basically when the data gets to the event structure, it waits for 250 milliseconds for something to happen, and for one of these to have an opportunity to run. And if none of these have the opportunity to run, then timeout case will run, which will send it to UI update. Currently I have nothing in UI update, but if you ever had something on the front panel which had to constantly update itself, then you would put that update inside UI update. And we don't do any actual logic inside this event structure, so if you look through here, most of these are just kind of telling it what state to go to, and then in that state we'll take care of actually doing some stuff. But in here, for the sake of keeping it simple and making it easy to debug and making the program more efficient, we don't do any actual programming in here, actual thinking in here. So just for an example to see how this case structure works, I'm gonna go through how the actual search works. So if you clicked on search, what would happen? So let's just double click on this. So when the value of search temp, this particular indicator, changes, this state will run. So as soon as you click on that, the value, if it changes to true to false, false to true, whatever it may be, this state will run. And if that value change was true, it turned to a true, then the next state will be search temp. So we'll feed that into the next state, and then the next time this loop runs, it won't run into this. It'll go straight to search temp, which is here. So what search temp does, source 2 is this indicator, and source 1 is this indicator. Okay, so this indicator is called source, and this indicator is called source 2.